Okay, now we're good. So arc length, if theta, right, theta is this little circle with a line through it, is a central angle in a circle with radius r, then the length of the intercepted arc, s, is given by, as in the formula is, s equals radius times theta. Okay? So again, if you look at the picture over here, theta is this angle right here. S is the intercepted arc. So that's the intercepted arc right there, right? And radius is always radius. That's radius. This is also radius over here, right? Because we go from the center of the circle to the edge. Key to highlight, write down something. It's got to be in radians. So they'll always, not always, but many times they'll give you that theta in degrees. You have to switch it to radians. Anybody remember from yesterday how to do that? Pi over 180 or 180 over pi to get it in radians. Pi over 180, right? Because radians has pi, so you have to remember the pi has to be on top in that formula. Okay, first one's easy because it's already in radians. Right? We got radians right here, so all you do is just plug into the formula. So get your graphing calculator out if you don't have it out already. S equals 5 pi over 6. Times, or actually I want to move that over. We'll do radius first. So 3 times 5 pi over 6. Right, you can put that whole damn thing in your calculator. So 3 parenthesis 5. Pi is above the little caret right here, so you go second caret to get the pi. Divided by 6, close that parentheses, and you get 7 point, rounded to tenths is what? 7.9, right? 5 and above, give it a shove. Okay? Okay, so equals 7.9. What is the units? Feet, good. Right? Find the length, again, you can just read this, right? Find the length of the intercepted arc, given the angle measure and radius. Give your answers in terms of pi and rounded to the nearest tenth. Did we give it in terms of pi? No, we didn't. What is, do this in your head in terms of pi. What is that in terms of pi? 15 pi over 6 reduces to? Ooh. 5 pi over 2, right? So I like to cross cancel personally. Students, for whatever reason, don't. They like to make their life harder, not easier. Make your life easier. 3 divides in 6, how many times? 2 times. So in radians, it's 5 pi over 2. I just forgot to write that. Okay? So they want it both ways, right? So you're going to round to tenths. So let's do number 5. We have to convert to radians, so it says the bubble. So we do 15 times, what is it? Pi over 180, 180 over pi. Pi, we want radians, so the pi's got to be on top. So you can do 15 divided by 80, 180 rather. Math, enter is your friend. So that answer is pi over 12. Okay? So 15 divided by 80, math, enter. We get pi over 12. That is not a 12. My brain was thinking ahead. So S equals radius times theta. So what's the radius here? 8.4, don't make that hard. Times pi over 12. So I'm going to do 8.4 divided by 12. First in the calculator. So 8.4 divided by 12, math, enter. So 7 pi over 10 in radians, okay? You should feel like that math, enter is the greatest thing ever right now. And when we do 7 pi divided by 10 in our calculator, we get 2.2 what? New units. Meters. Okay? So if you forget the units, how many points do you miss on a test? just a half point, right? Because you understood most of the problem. I shouldn't take off 2 points. That's stupid. Okay? Some of your former advanced or regular teachers may have like harshly taken off points. I find that dumb, so I don't do that. How about you do number 6 on your own? I'm going to write the answers up here, okay? So you're going to work on 6. I will freeze the screen, do it up here. Any football players in here? None. Weird. Anybody go to the football game last night? Yeah, it was a good game, huh? Pure domination. Gotta love it. You should have got that for radians. In radians, the answer was this. And in millimeters, the answer is this. Okay? How many people got that right? This is maybe a little too fast. Okay. All right, we're going to do number 9 next, because we don't need to keep doing the same thing over and over again. So we got a little circle. That's not a circle. Okay, we got this. We got... This one is kind of funky. So we got this. Our radius is 6. The measure of the intercepted arc is 10. So if we think about our S equals radius times theta equation, what 2 parts do we have? What's the 10?
That's S.
That is S, good. So 10 is the S. The R is 6, right, from the center to the edge of the circle. This is also 6, right, because we can go to any edge of the circle, it's still radius. So we have 6 times theta. So if we think about that formula, it's in radians. How would we solve for theta? Divide by 6. Don't hurt yourself thinking. It's going to be okay. And then if we do 10 divided by 6, math enter, we get 5 over 3. Here's my question for you. Do I need to put a pi up there for radians? Yes or no? Why not? That's correct, Isaac.
Because there's no pi in the original equation.
Good. He's on the right track. I'll give him that. So when I do this formula, what did it say up here in this highlight? It's in radians. So if they give me S, that means radians is already in there. So the pi is already in there. Okay, because it'll mess you up on the homework because you'll try to put a pi in there and you get the wrong answer and you're confused why. So this includes the pi already, right? So it's not 5 pi over 3. It's that pi is already included within. And then we plug it in. So theta is 5/3 radians. You could write radians there if that maybe even in your different color. Write radians so you remember. Like for me, I would have to write, it's already got the pi. Okay, and then I'd remember that. And now we can plug, we want the degrees. So when we get the degrees, we're just going to go 5/3 times 180 over pi. So that's the weird part, right? So there's no pi's to cancel. We just have to multiply that in our graphing calculator. And we'll get some, we're doing 180 divided by 3.14, right, as part of that problem. So that's just kind of the weird intricacy of that. So we're going to go, always use parentheses when you're doing this kind of stuff, because you'll get it right. Why would you want to get a math problem wrong? It's irritating. Second caret to get the pi in there. And you can put it in just like that. If you just put times in the middle, weird stuff happens. Because you all know the order of operations. You just choose not to follow the order of operations sometimes. right? So when you put a bunch of divides in your calculator, you're not sure what's multiplying and dividing as you go. So if you just put the parentheses, you kind of force it to do what you think it should do, and you're better off that way. So 95.5 for that answer. And what is my symbol on this one? My units. Degrees, right? Because they want to give you your answer in degrees. It's okay if you say the wrong thing. Like, I appreciate the effort, right? So don't ever feel stupid about it. Like, you're trying, you're paying attention. That's a good thing. Okay? We're doing number 10 and 11. So 10, a merry-go-round rotates 2,808 degrees per ride. So it goes around in a circle a bunch of times, right? Merry-go-round. How far would a rider seated 8 feet from the center of the merry-go-round travel during the ride? What's 8 feet?
Radius.
That's a radius. So I put R equals 8 feet, so I know that, right? And then 22,808 is our theta. So what do I have to do to it to put it in radians?
180 or pi over 180.
Right? Because I need the pi on top for the radian, so I got to do pi over 180 exactly. And I'm going to do 2808 divided by 180. Math, enter, enter. Oops. And I get 78 pi over 5 when I do that. So when I plug into my S equals radius times theta formula, I don't have S, but I do have the radius, which is 8. And I do have theta, which is 78 pi over 5. And when I multiply that in my calculator, I should get 392.1. What are my units? Read the problem. What are my units? Feet. Good. You see I'm encouraging you to look at the problem to remember what the units are? Because I forgot units all the time when I was in high school and college, and it irritated me when I'd lose those little half points. My favorite thing to do to you, which I don't know if I've said or not before, is the kid that gets a 99, right? I look through their tests like hard, and I'm trying to find little tiny mistakes that it can take points off just because I find it amusing, right? So if I find a unit that you missed, I write -1/2, haha, just to rub it in a little bit, right? And then why do I do that? To be cruel, sure. But also because you're more likely to remember units in the future. You read that little haha and you get a 99 and you're like, Evans, right? You get super pissed off. And it's kind of funny. I laugh and I hand it back to you and you're like, oh my God, what did I miss? So you're more likely to remember because we have that little kind of funny moment, right? I'm not being a total jerk about it, but you can take it that way if you want. I don't really care. Okay, so this next one's kind of weird, right? So read 11. We just have like 3 or 4 more problems left, okay? And then you get homework time. So read 11, try to understand what the hell's happening, because it's a little funky. I'm drawing a little circle here. So I'll read it too. Cincinnati, Ohio is directly north of Atlanta, Georgia. Cincinnati has a latitude of 39.1 degrees north, and Atlanta has a latitude of 33.7 degrees north. If the Earth has a radius, so it tells you straight up what that is, right? So R is 3960. How far apart are these cities? Okay. So what are my units going to be? Miles. Good. Okay. So what do I have to do with 39.1 and 33.7? Right? I subtract them. And when I do so, I get 5.4. And then I have to change it to radians, so I multiply by pi over 180. So I'm going to go 5.4 divided by 180, math, enter, enter. When I do that, I get 3 pi over 100. So we have theta in radians and we have the radius, so we just multiply those two together and that's our answer. Okay, so we do S equals, the radius is 3960 times 3 pi over 100. And that equals something, 373.2 miles. Okay, so like they're reasonable story problems, right? And if you get some wacko answer like 5,000, you know you screwed something up, right? So like when I do story problems, I look at the answers and see if it makes relative sense. I personally think that Cincinnati and Atlanta are more than 373 miles apart. Because when I was a kid, I used to drive from Cleveland south of Atlanta and it was 17 hours. And it was a hell of a lot longer than 373 miles, right? How long would that take you to drive? 6 hours, right? How fast are you going? Depends how fast you go, right? Right? 3 hours. You're going like 120, right? Don't do that. I see some of you drive out there. It's scary. Okay. All right, so we're doing area of sectors. So when they talk about sectors, they're talking about like the shaded part right here. That's a sector of the circle, right? So we're still going to use theta, we're still going to use r, but area, it's triangle-ish in nature. So we're going to have area equals 1/2 times theta. And then it's area, right? So it's not just r, it's r squared. So when we get area, it's always going to be units squared as well because we have 2 dimensions, right? So that's why it's units squared. If it's linear distance, that's just whatever the units are. If it's area, it's units squared. If it's volume, what is it? How many dimensions for volume? 3, so it's got to be units cubed, right, for volume. That helped me to figure out which one was which when I was a student. So if that works for you, good. All right, so again, we have to have this sucker in radians. I would highlight, underline that start so you remember. But is it always in radians? So remember, it's always in radians, right? So we got to take that 74 degrees and we're going to multiply by pi over 180 because we need the pi. And then we're going to reduce that in the calculator. When we do that, we should get, anyone know what that is reduced in their head? Because they're just both even, so it's got to be 37 pi over 90. And then we can plug it in. I personally would plug in using 0.5 instead of 1/2 just because it's easier in the calculator. So 0.5 times 37 pi over 90 times the radius squared, which is 4 squared for this problem. And plug that. I plugged the whole damn thing in the calculator. On your homework, when I come around and check, after checking first period pre-calc, some people would just write what this answer is as their homework. I pretend like you never did that problem. Okay? Just so you know, I'll give you credit today because you're learning how I grade your homework. But you got to write at least that down with the answer so I know what you plugged in to get that answer. Okay? When you plug that into your calculator, you should get 10.3 centimeters squared. I would definitely plug a few of these into your calculator to make sure you're not screwing something up when you plug it into your calculator because it's easy to make stupid mistakes. Let's have you do 13 on your own. I will show you what I plugged in and the answers, including switching it to radians, so you can double check your work. And when I give you moments like this to try the problems, do it. Sometimes you get lazy because it's easy to watch me do math up here and you think you get it until you get home and try the homework and then you're like, what happened? Make sure you throw the units on there. I've said that like 28 times this class period already. That's what you should have got. That's some steps along the way as well. This is what I expect you to show me on your homework too. For this kind of problem, you should have that amount of work. If you look at Gina's solutions, she doesn't show that amount of work. I want you to show more than she does. I can tell you copied the solutions because I know what they are. So don't copy those solutions, right? Are we good on that one? Any questions? You got a perplexed look on your face. You good? Are you sure? You just don't want to admit it, huh? It's okay. All right, we're going to do 16 and 17 and then we're done. 16 is relatively easy, 17 is not. Okay? So 16 says the area of a sector of a circle with a central angle of 240 is 134 feet squared. So if we think about our area formula, we'd have 0.5 times, what was it? Yeah, theta to r squared. Do you think I'm going to give you this formula on a test? Hell no. What should you do for that formula? Make a flashcard. Flashcard moment. Woo woo. Good times. Right? So both those formulas, I would have flashcards, have the name of the formula on one side, flip it over, and then make sure you put in radians on the back of your flashcard. Okay, so when I look at these two numbers in this problem here, I got 240 and 134 feet squared. What's what? What's the 240? It's an angle, yeah. But it's theta in this formula, right? So I need that 240 in radians. So right away I know I got to do pi over 180. Okay? So when I do pi over 180 there, I get 4 pi over 3. So now I got theta, right? I got this one right here. I've already got the 0.5. What's the 134 in that formula? Is it A or radius? Area, right? How can you tell without even thinking about it? Because the units are squared, exactly. Like, it's a good cheat code, right? You see the units are squared, it's got to be the area. So plug it in where the area is. So we get 134 equals theta, or we got the 0.5 rather. And then theta is 4 pi over 3. And then that equals, or it doesn't equal, times r squared. So if it's me in the graphing calculator, I'm going to do, well, if we do 0.5 times 4 pi over 3, what do we get? What's half of 4 pi over 3?
4 pi over 6.
4 pi over 6, right? Because we're multiplying by 1/2. 4 pi over 6 reduces to what?
2 pi over 3.
So you could think like what's half of 4, 2, and do it that way. You could also say 4 pi over 6. They're both right, because you're just going to plug it into the calculator, right? So I'm going to divide both sides by 2 pi over 3. So I'm going to put that whole thing in my calculator. And I'm going to put this in parentheses in my calculator when I divide it so I don't screw it up. I encourage you to overuse parentheses when you put it into your calculator because you're more likely to get it correct. So we're doing 134 divided by 2 pi over 3. Just wait till you get to the next one. 134 divided by 2 pi divided by 3, like that. And you should get 63.98. Now, what does that equal? That equals r squared. So what do I have to do with this number? I have to square root it. So in the calculator, super handy, you go second x squared. It gives you the square root symbol. And then you go second down here, right above the negative, it says A and S. That means answer. Okay, so you go second x squared, second negative. And then it'll take that whole decimal thing and throw it into the square root. And that is the most accurate answer. Because sometimes you guys round along the way. And when you round along the way, weird stuff happens. An example in real life is the Mars rover. They landed that thing on the wrong side of Mars. They landed it on the wrong side of Mars because somebody it was conversion between feet and meters. And they didn't keep all the decimal places. I'm surprised they even hit the planet, to be honest. You think about landing on the wrong side of Earth, like that's significant, yeah? But Mars is really far away, right? So it's kind of impressive they hit the planet at all, but they landed on the wrong side of the planet. Do you think somebody got fired? Oh, hell yeah, right? If you land that thing on the wrong side of the planet, you know how much planning goes into putting it on the right side of the planet? A ton. And if you're on all the way on the other side, like, could be super cold, super hot. Like, I don't know enough about Mars, but all sorts of weird crap could happen. So second square root, second answer, enter. And what does that round to? Because we're rounded to tenths, 8. So we get 8 feet. And it's radius, right? So it's just feet, not feet squared. Okay? Any questions on that one? Good. All right. This one's weird. So, windshield wiper arm to the left is 32 inches long. So that means this whole thing is 32 inches right here. Okay? So for me, I'm going to kind of draw it off to the side because I'm also going to get this distance right here. So we know this whole distance is 32, right? From where it connects to the car all the way up to the top of the blade, that's 32 inches. If the wiper sweeps through an angle of 125 degrees, so they're talking about this angle right here, right? So it sweeps through 125. What do we have to do with that 125 right away? Pi over 180, right? Should be getting used to that by now, right? Pi over 180. So when we do that, 125 times pi over 180 is 25 pi over 36. Divide top and bottom by 5. Okay, so what is this blue distance right here? Look at the whole picture. 11, yeah? Right, because that 21 is this distance from here to here. So this distance is 21. Which means there's 11 left over for the bottom part of it, right? Because this is 21 right here. Okay? It's like the radius. You can draw from the center to the edge anywhere along the picture, right? And get the radius. Same relative concept here. So this right here is 21, and this is 11. Okay. So we have to figure out two areas because they want us to find the area of this part in here, not this part. So we're going to get both of those areas. What do we have to, or actually we're going to get all of the area together minus the 11 radius area, and we're going to subtract those two. So here's how I write it so I can tell, and here's how I want you to write it as well, right? A sub 32. So we're using 32 in that equation, and we're going to plug it into our area equation up here, right? So we get 0.5 times 25 pi over 36 times, it's a 32, so it's 32 squared. Then we're going to do the same thing with the 11. So the only thing changes, the 32 changes to 11. Everything else stays the same. So when I throw the top one in, I get 1,117. It's inches squared. When I do the bottom one, I get 132 inches squared. And I'm going to subtract those two areas, and I get 985 inches squared. Okay? That's the blue shaded area in that wiper blade thing. Any questions?